Hello friends, welcome to Online Physics. So today we are going to discuss about the problems of quantum mechanics of CSIR-NET December 2019. And this is part A, in which we will discuss about the problems of 3.5 marks. And in the next part we will discuss about the problem of 5 marks. So friends, this video will be very helpful for all of you because previous problem से आपको आइडिया होता है कि किस तरह की प्रॉब्लम्स एग्ज़ाम में पूछी जाती हैं और किस अप्रोच के साथ उसको सॉल्व किया जाता है. So let's start. So let's start with the first problem. So the problem is the energy eigenvalues of a particle of mass m confined to a rigid one-dimensional box of width L are En. Here n is quantum number which may be 1, 2 and so on. If the walls of the box are moved very slowly toward each other, the rate of change of time-dependent energy dE2 upon dt of the first excited state is. So किसी भी प्रॉब्लम को सॉल्व करने की बेस्ट अप्रोच यही है कि सबसे पहले उसमें गिवन देखो क्या दिया हुआ है, देन उसके बाद हमें क्या फाइंड आउट करना है. अगर तो गिवन और जो फाइंड आउट करना है उसमें डायरेक्ट रिलेशन बन रहा है तब तो आप डायरेक्टली फाइंड आउट कर सकते हो, और अगर उन दोनों में डायरेक्ट रिलेशन नहीं बन रहा तो आपको वहाँ से रिलेशन क्रिएट करना है कोई थर्ड इक्वेशन यूज़ करके. सो दैट्स द अप्रोच टू सॉल्व द प्रॉब्लम. सो नाउ अगर हम इस प्रॉब्लम की बात करें तो यहाँ पे हमें वन डिमेंशनल बॉक्स का सिस्टम दे दिया जिसकी विड्थ L है और उसमें पार्टिकल है, उसका मास m है and energy is En. And the next thing is the walls of the box are moved very slowly toward each other. That's mean L is changing with time. And here we have to find out the value of dE2 upon dt. And here E2 is the first excited state. And these are 4 options. So let's see how to solve this problem. So here we have to find out the value of dE2 upon dt. And here we know that energy for this system is En equal to n square pi square h cut square upon 2 ml square. And for ground state n is equal to 1. But here we needed the energy for the first excited state. So here for first excited state n is equal to 2. So here E2 will become 2 square pi square h cut square upon 2 ml square. So that will become 4 pi square h cut square upon 2 ml square. That can be written as 2 pi square h cut square upon ml square. Now here we have the value of E2 and we can easily find out the value of dE2 upon dt. So just take the derivative with respect to time of E2. And here L is also the variable of time and all the other terms are constants. So this will become 2 pi square h cut square upon m d upon dt 1 upon L square. So the derivative of 1 upon L square is minus 2 upon L cube into dl upon dt. So to match the answer with the options, we just have to rearrange these terms. So after rearranging, we will get minus 2 upon L dl upon dt into 2 pi square h cut square upon ml square. So here this term is equal to the E2. So we can write here E2. So here the answer will become minus 2 upon L E2 dl upon dt, which is option C. So here option C is minus 2 E2 upon L dl upon dt. So that's mean option C will be the right answer. Now let's come to the second problem. So the problem is two spin half fermions of mass m are confined to move in a one-dimensional infinite potential well of width L. If the particles are known to be in a spin triplet state, the ground state energy of the system in unit of pi square h cut square upon 2 ml square is. So यहाँ पे हमको simply ground state निकालनी है in the unit of pi square h cut square upon 2 ml square. So in this problem we have given an infinite potential well of width L. So here we have to find the ground state for the triplet state. So for triplet state we know that total spin will equal to 1. Triplet state means two fermions of same spin. So same spin, and that's why total spin half plus half will equal to 1. And we know that according to Pauli exclusion principle, two particles of same spin cannot be in a single state. This is not singlet, this is single state. So that's why both the particles are not in the N1 state. One particle in the N1 state and one should be in the N2 state. So the total ground state energy will become the sum of the energy of both the states. So for the first state n will equal to 1 and for the second state n will equal to 2. So simply put the value of n. So we will get 1 square pi square h cut square upon 2 ml square plus 2 square pi square h cut square upon 2 ml square. So after adding both these terms we will get 5 pi square h cut square upon 2 ml square. So this will be the ground state energy for this system. And according to this problem we have to find the energy in units of pi square h cut square upon 2 ml square. So here 5 will be the right answer, which is option D. So here option D will be the right answer. So now let's come to the third problem. So the problem is a particle of mass m is confined to a box of unit length in one dimension. It is described by the wave function, and the wave function is under root 8 upon 5 sine pi x into 1 plus cos pi x for x between 0 to 1 and 0 outside this interval. The expectation value of energy in this state is, so in this problem we have given a wave function and we have to find the expectation value of energy. So now let's see how to solve this problem. So here we have find the expectation value of energy, that is equal to C1 square into E1 plus C2 square into E2. And here C1 and C2 are the constants of first and second states respectively. Now here we know the energy for this system, that is equal to En equal to n square pi square h cut square upon 2 ml square. So for E1 simply n is equal to 1 and for E2 n is equal to 2. So here we can easily write the value of E1 and E2. So that's mean we have to find here the values of C1 and C2. Now here the given wave function is under root 8 upon 5 sine pi x into 1 plus cos pi x. So just open the bracket and we will get under root 8 upon 5 sine pi x plus under root 8 upon 5 sine pi x into cos pi x. So simply अब हमको यहाँ पे क्या करना है, फर्स्ट स्टेट के लिए और सेकंड स्टेट के लिए वेव फंक्शन यहाँ पे क्रिएट करना है और उसकी जो कांस्टेंट वैल्यूज़ होगी वो हमारे पास आ जाएगी वैल्यूज़ ऑफ C1 एंड C2. So we know that how to write the wave function for this system. So the wave function is under root 2 upon L sine n pi x upon L. And here the value of L is 1. So simply the wave function is under root 2 sine n pi x. So for the first state n will equal to 1. So wave function will become under root 2 n pi x. And for the second state phi 2 equal to under root 2 sine 2 pi x. So let's create this wave function. So in the first term just multiply and divide with the under root 2 and we will get psi 1. And here we know that 2 sine pi x and cos pi x equal to sine 2 pi x. So that's why we have to multiply and divide this term with 2. So here to create this we also have to multiply and divide this term with under root 2. So after simplifying this term we will get under root 4 upon 5 under root 2 sine pi x plus under root 1 upon 5 into under root 2 sine 2 pi x. And that can be written as under root 4 upon 5 psi 1x plus under root 1 upon 5 psi 2x. So from here we will get the value of C1 and C2. So C1 is equal to under root 4 upon 5 and C2 is under root 1 upon 5. So by using equation 1 we will get the expectation value of energy. So here the first term is equal to C1 square into E1. So here C1 square is 4 upon 5 and E1 is 1 square pi square h cut square upon 2m. Because here L is equal to 1. And the second term is C2 square into E2. So C2 square is 1 upon 5. And E2 is 2 square pi square h cut square upon 2m. So after adding this we will get 4 upon 5 pi square h cut square upon m. So this is the expectation value of energy. So here option B will be the right answer. Now let's come to the fourth and last problem of this video. So here the problem is the normalized wave function of a particle in 3 dimensions is given by psi xyz equal to nz exponential minus a x square plus y square plus z square, where a is a positive constant and n is a normalized constant. If L is the angular momentum operator, the eigenvalues of L square and Lz respectively are. So here we have to find out the eigenvalues of L square and Lz. So we know that L square equal to L plus 1 and Lz equal to ML h cut. So that means simply we have to find out the value of small l and ML from the given wave function. So here the given wave function is nz exponential minus a x square plus y square plus z square. So here he is talking about the angular momentum. So we have to change this system into the spherical coordinates. So in case of sphere, x square plus y square plus z square is equal to r square. And we know that x is equal to r sin theta cos phi, y is r sin theta sin phi, and z is r cos theta. So just put these values in the given expression and we will get psi r theta phi is equal to n r cos theta, because z is r cos theta, and exponential minus a r square. And we know that polar form of wave function is directly proportional to pl cos theta exponential iota ml phi. So just by comparing above equations we get the value of ml that is equal to 0, because in this equation we have not any value of phi. And we know that exponential of 0 is equal to 1. So just multiply this equation of exponential of 0. So from here we will get the value of ml that will equal to 0. And from here we will get the value of L that is equal to 1. So here L square is equal to L plus 1, and that will become 2 h cut square. And Lz equal to ML h cut. So here ML is equal to 0. So here we have 0 h cut. So eigenvalue for L square is 2 h cut square and eigenvalue for Lz is 0. So here option C will be the right answer. So these are the 4 problems of quantum mechanics of 3.5 marks of previous NET exam. And in the next video we will discuss about the problems of 5 marks. So thanks for watching, keep learning and keep sharing. Thank you.